8.4, effect of density of population. Essential question: how can the density of a population affect its growth? And also, how would limiting factors such as resources affect the size of a population? In the 8.3 video, we talked about what factors affect the size of a population. It affects the birth, the immigration, the death of a population in a population, and emigration. These are the 4 parts. But in our video, we said everything was unlimited at that time to check out the exponential growth. Now, resources are limited, although that means the food supply for the population, when it's less, the survivalship will decrease, as well as the reproduction. The death rate will increase among the organisms. The immigration will decrease, and the emigration would increase. More organisms would leave the population. On the other hand, when the food source is more or ample, what happens with those survivalships, reproduction, death, immigration, and emigration? They move into the opposite direction. But not only the food is the limited source, but the shelter and the territory where the organisms can live, the water source, as well as the diseases act also as density-dependent factors, because these are the factors when the density of a population matters for its size. Not only density-dependent factors exist, but also density-independent factors we distinguish for. They are the ones that it doesn't matter how big the population is, they affect the population, such as drought, flood, natural disasters, earthquakes, volcanic eruptions. These are all density-independent factors. Now, for the growth, we modeled the exponential growth when the factors were unlimited. Now, density-dependent factors affect the growth of a population. So the growth model, if we want to just graph it, we would have a S-shaped curve, that the plateau of the S shape is really the carrying capacity for that population. I put it into a question mark, quotes the question mark, because we do not know the size. We just estimate it. This growth model is a mathematical model, and I want to just describe the growth of a population. Now, the growth of a population depends on the rate of the growth times the size of the population, times with a correctional factor that depends on the carrying capacity and the actual size of a population. Let's check different scenarios, how the population grows at certain points. When the population is low, the N, the size of the population, is really small compared to the carrying capacity, so the correctional factor is really close to 1. So the growth of a population, the delta N over delta T, is R times N times 1. That is really similar to the exponential growth rate. The R is the growth rate. Now, the second scenario will be for us when the population is close to the carrying capacity, but it's not reaching it yet. So the N is very close to K, but not the same still. In that case, the correctional factor is close to zero. It's not zero, but close to zero. So the growth of the population is R times N times close to zero. So it will be very close to zero, the growth. So it's a low growth rate, growth at that time. Number three, scenario number three will be when the population reaches the carrying capacity. At that time, the growth is zero because the correctional factor is zero. So what is the value for the K? Actually, we do not know. This is a mathematical model. Try to represent the growth, but we do not know. When the population is low, the growth is low. When the population is really reaching its high value, again, the growth is low. But the fourth scenario will be, what about in the midway? When the population is half of the carrying capacity. This is when the growth of the population is the maximum. Also, the slope is really the maximum at that point. So for the question, how density of a population affects the growth? The answer is that the population shows a logistic growth, because resources really affect the growth and the size of a population. The growth of a population is limited. Thank you.